Hey, how you doing? I'm Elton, and this is the fourth part in the Docker MTA series, Modernizing .NET Apps for IT Pros. In part 3, I showed you how deployments and updates work using Docker Trusted Registry as a private store for Docker images and running containers in a Windows VM in Azure. A single server is fine for basic system tests, but you need a more realistic environment for UAT or pre-production testing. In this video, I'm going to deploy my app to a staging environment running on Docker using multiple servers for a scalable and highly available cluster. The clustering technology is built right into Docker. It's called Swarm Mode, and it scales from a single server right up to thousands of servers. I'll show you how to use Docker for Azure to create the swarm, how to deploy and scale applications in Swarm Mode, and how you can add monitoring to your apps so you can see what's happening inside your containers. You can create your own Docker swarm in the cloud by starting multiple VMs in the same network and running the Docker swarm init and Docker swarm join commands, but it's much easier with Docker Cloud. You link Docker Cloud to your Azure subscription or your AWS account, and then just click to create a swarm and select your cloud provider. You fill in the basic details like the region, the number of swarm manager nodes, and the number of worker nodes, and the VM sizes, and then Docker Cloud creates the swarm for you. Docker Cloud provisions a consistent Docker environment no matter which provider you use, making the best use of the features from that provider. Docker for Azure creates a virtual machine scale set for the manager nodes and another one for the worker nodes. You can manage capacity just by sizing the scale sets. Right now, Docker for Azure only provisions Linux nodes. Windows support is coming soon, but I'll show you how to add your own Windows nodes. I've created 3 VMs from the Windows Server with Containers machine image, which I'll add to the swarm. Docker Cloud makes it easy to deploy a highly available swarm running Docker, and it also makes it easy to manage that swarm from your local machine. Docker for Windows and Docker for Mac integrate with Docker Cloud. I've signed in with my account and I can see the swarms that I have running in Azure. I just click to manage the swarm and that opens a new window where the Docker command line is connected to the swarm. I can run docker node list locally and see all the nodes in my remote swarm. These are all Linux nodes, and to join my Windows nodes I need the secret token. Docker swarm join token worker shows me the command to join a new worker node to the swarm, and I can run that on my Windows VMs. Any node can join the swarm as long as it has Docker installed and has a network connection to the other nodes. My Windows nodes are all joined now. I have 3 managers, 1 Linux worker and 3 Windows workers. Worker 2 is a special node. It's running more memory than the other VMs. You can add labels to nodes in Docker Swarm to distinguish hardware like this, and I'm adding a label to say that this node has extra memory. You can deploy to Swarm mode using commands to create services, or you can use a Docker Compose file. This is the Compose file from the last video with some extra configuration settings. The constraint tells Docker to run these services as containers on Windows nodes. They're all Windows images, and this is a shortcut so the swarm won't try to schedule them on Linux nodes. Windows doesn't have all the networking features that Linux has, and Docker has different networking modes to support that. I'm using DNS round robin for services to locate each other, and in the web app I'm publishing port 8090 from the container to port 80 on the host. The database service is using a volume for storage. That means the SQL Server data and the log files are saved outside of the container directly on the host. The extra constraint here means the database container will always run on the node with extra RAM. This means the database is resilient to failure. If the container fails, the data is still there, and when a new container starts, it will attach the existing data files. A distributed application like this, running on multiple containers, is called a stack in Swarm mode, and I deploy it on the swarm with docker stack deploy, specifying the path to the compose file and a name for the stack. The images are on my private registry, and the with registry auth flag means the worker nodes can use the credentials from the manager to pull private images. The swarm managers schedule work to run on the worker nodes, and the nodes will pull all the images they need and start containers. Docker for Azure creates a load balancer in front of the scale set for the worker nodes, and I've done the same for my Windows nodes, using a health probe so traffic only goes to the nodes which have containers listing on that port. I'll browse to the public DNS for the load balancer, and here's my application. This is the same v3 image that I've used before, so it's the exact same application package that I've tested locally and on my single server in Azure. I've just got one container hosting my app, so the load balancer will send all traffic to that node. In swarm mode, you can scale services and have multiple containers running which are replicas of the application image, all handling traffic. Docker service update with a new replica value scales the web application to use 3 containers. Docker Swarm spreads containers across nodes, so I'll end up with one container on each Windows node. Any worker could get incoming requests from the load balancer now, and the container on the node will respond. When I refresh the site, it works in the same way, and any one of the containers on the Windows nodes could be handling the request. Services can run across many containers, but you can still check the logs with Docker service logs. That shows the replica ID with each log entry, so you can see the logs from all containers. That's useful for debugging when you have a problem, but for ordinary monitoring, it's better to have instrumentation in the containers. IIS applications write a lot of metrics to Windows performance counters. That still happens when you're running in Docker, and you can see those metrics if you export them from the container. Docker has a huge ecosystem of partner and community products, including a very popular instrumentation server called Prometheus. You run Prometheus in a container and use it to poll other containers and collect their metrics. I've updated my web application Docker file to publish performance counters as Prometheus metrics. I'm using another Docker image from a sample project as the source for an application which reads performance counters and publishes them as Prometheus metrics. This is the setup for that exporter program, and I'm using a config file with all the performance counters that I want to capture. These are the main .NET and IIS counters. I've also changed the startup command, so the exporter app is running in the background when you run a container, but I haven't changed the website at all. This is still the same code that came from the Windows 2003 VM. I'll build this as version 4 of my app image, and when I run it locally, the app still works in the same way. But there's an additional endpoint I can browse to, which shows me the performance counter values as metrics, like the number of requests per second. This is the endpoint that Prometheus will monitor. Prometheus uses a simple configuration file to specify endpoints, and in this setup, I'm checking the web app every 5 seconds. In the compose file, I've updated the web application to use v4 and added a service to run Prometheus. Normally, you wouldn't make your metrics publicly available, but I'm doing that just for this demo. I'm still connected to my swarm, so I'll run docker stack deploy again, which updates the stack and brings it into line with the new compose file. This update is a zero downtime deployment, because Docker updates the web application one container at a time, and the load balancer won't send traffic into a node that's being updated. When I refresh the website during the update, there's no loss of service. This update also adds the Prometheus server, so I can browse to port 9090 and see the metrics being collected. This is the number of requests currently being handled. I'll start some load running with a PowerShell loop, and in the graph view you can see that the load on the website changes over time. You can do a lot more with monitoring in Docker. Prometheus is just one option, but this is a simple way to get insight into your applications in a modern platform without having to change code. At the start of this video, my app was running in a single server in the cloud, which is fine for a basic test environment. But now my app is running across multiple servers in a Docker swarm, which I created with Docker for Azure, and which I can manage and extend using ordinary Azure resources. I've deployed my app as a set of highly available services in the swarm, so if there is any interruption to my VMs, the app will keep running correctly. High availability works for application updates too. I added monitoring to my web application by exporting the Windows performance counters, and deployed a new version of the app with zero downtime. I touched briefly on instrumentation, and running in Docker makes a huge difference to how you administer and manage traditional applications. Every application in a container has the same shape, and you can manage 10-year-old .NET applications and brand new Node.js applications on the same Docker swarm using the same tools. In the next video, I'll show you how production looks in Docker, and it's the same in the cloud and in the data center. I'll run my app on Docker Universal Control Plane, which is an enterprise-grade containers as a service product which is built on top of Docker Swarm. I'll focus on management and security, showing you how role-based access control and content trust enable you to have a secure software supply chain. That's coming in the final part of Modernizing .NET Apps for IT Pros.